Alright, so hyperbolas are going to be kind of a lot like ellipses in that there's a lot of messy information. But if you pay attention and you understand this concept, that like the ellipse, you find the distances between the points and the foci, and then you add them. The hyperbola is very similar, except we're going to be subtracting them. Okay. Alright, and so the foci are going to be located inside. Now these are going to be like twin parabolas constrained by these asymptotes right here. So you're either going to have them both going up and down or left and right. Okay. Alright, so it just depends upon which one you have. Now to notice the difference between the two, the x comes first in the horizontal and then the y comes first in the vertical. Okay, that is just a simple, it's an easy recognition of which set you're going to be dealing with. Okay. Alright, so hyperbolas, once again, the subtraction of 2 points of the distance between the point and the foci, those two, just everything all taken care of like that. Okay. Alright, so foci are right there. Okay, now the actual transverse axis. Okay, the actual transverse axis will be between the two vertices, and the vertices are going to be in their usual spot. They're going to be right here and right here. So your vertices will be located right there. Okay, so vertice and vertice. Okay, all right. So this is going to be the transverse axis. Okay. All right. Now the conjugate axis, oh, and this one will be too, so this will also be the transverse axis. Now the conjugate axis is going to be the other. Okay, now the conjugate axis is going to be this way. Now the conjugate axis and the transverse axis, they're going to be a little bit complicated at first, but once you start to notice what the conjugate axis and the transverse axis make, it's going to make your job a whole lot easier. Okay, what they're going to be making is they're going to be making a square that the corners are going to be how my asymptotes are set up. So this one's a little off. Let's shorten that up a little bit. Okay, and it should make a perfect square most of the time, especially when you're not trying to do this by freestyle hand. Okay, so they're going to be those lengths right there, and these corner points are actually going to make up the actual asymptotes that you're going to use to draw the actual shapes. Like back in the day before we had graphing calculators, well, yeah, back in the day before graphic calculators, you had to use the transverse axis and the conjugate axis to actually get that information out there. Okay? Alright, so conjugate axis, it's a little bit tricky, but it's just like transverse axis. It just gives you this length right here. Okay, the center of the hyperbola, for our sake, we're just going to deal with them centered at the origin. Okay? Alright, and the axis of symmetry is actually going to be going right through the actual foci. So it's going to be going like this direction, and this one's going to be going this direction. Okay? Alright, and the vertex of the hyperbola, once again, is going to be the points. It's going to be basically the vertices of the two parabolas made. Okay, so on to the formula. Alright, foci, you need to find C to get it, and A is all you need for the vertices. Okay, now obviously if we did the conjugate axis, you could actually use B, but we're not going to deal with that as much. Okay, so how do we find C? C is found by this formula, which, as you know, is the almost conjugate opposite of the ellipse. The ellipse was a squared minus b squared, where a was bigger. Now it's a squared plus b squared. So we really don't care whether a or b is bigger. Okay, and they can make different hyperbolas from that. We just care that you understand that it's going to be a squared b squared, and the only thing we really care about is what letter comes first, because that will tell you if it's a vertical or a horizontal hyperbola. Okay, now the asymptote is the new formula. So we already know how to do foci and vertices, so that's pretty simple. But the asymptote is all you need is b divided by a for horizontal, for the horizontal vertices right here. Okay, not the horizontal vertices, the horizontal hyperbola that we are dealing with. Okay, and then for the asymptotes of a vertical hyperbola, you're going to do a divided by b, and obviously the c and the a are all going to be flip-flopped from what you're used to. Okay, or from the horizontal. All right, now we're going to take a look at the graph and just work with that real fast. Okay, so here's my graph of a hyperbola. Okay, so it's going to be x squared over a squared minus y squared over b squared equals 1. And then one of my asymptotes is going to be b over a times x. And the other one's going to be negative b over a times x. Okay, so I'm going to mess around with b and a. Alright, so as you can see, as I make a bigger, obviously this becomes a skinnier and shorter horizontal asymptote, and obviously as it gets bigger, as it gets smaller, we get a much more different looking asymptote. Okay, let's go to 6. Okay, and B does the same thing too. So as I move it around, it changes the actual shape. Okay, all right, and so that's just how you actually graph it and just take a look at it. Now you can also set up one to where it's the other way and where it's vertical. Okay, and you can mess with it. It's kind of cool to see how it actually works out. Okay, and this is actually going to bring me to a point I'm going to talk about, especially eccentricities in a second. Okay, all right. Okay, now what are the foci, vertices, and asymptotes of the hyperbolic equation 9y squared minus 7x squared equals 63? Okay, first off, I want to direct your attention. Y is first, so this is a vertical hyperbola. So we're going to be dealing with finding y squared divided by a squared minus x squared divided by b squared equals 1. That's the formula we're going to be getting into. Okay. All right. Now, if you notice, this is going to be a lot like the elliptical formula. I need it to equal 1, so I'm going to be dividing everything by 63, and then reducing like none other. So I'm going to reduce all the fractions. Okay. And so my fractions are going to look like this: y squared divided by 7 minus x squared divided by 9 equals 1. Okay. Alright, so the number under the front is definitely going to be a, so this is a squared. Okay, and yes, that is a 7, so we're going to be dealing with some funky stuff. Okay, so to find c squared, we need let me see, what is that? 7 plus 9. And that equals 16, which should equal 4. Okay. When we square root it and everything. Okay, so the foci, and this is dealing with, let me see, vertical. So the foci are going to be 0, comma, plus or minus 4. Okay, so that's the foci right there. Alright, now the vertices are going to be the a's of the group, so it's going to be 0, comma. Now we're going to square root the a, so this is going to be plus or minus the square root of 7. Okay, so those are going to be the two sets of vertices. Okay, and then the asymptotes, if we use our formula sheet correctly, it should be y equals plus or minus, let me see, a, which is the square root of 7 divided by 3x. And voila, we have everything all set up to where I can actually find the foci, the vertices, and asymptotes of a hyperbolic equation, as well as actually find the hyperbolic equation that we're dealing with. Okay, now since we're at the end of all of the conics, I want to talk to you about eccentricities. Okay, Okay, so eccentricities are actually calculations that you can use to actually find out what kind of conic you're dealing with. So at eccentricity equals 0, we get a circle. For when the eccentricity is between 0 and 1, we get an ellipse. For when the eccentricity is equal to 1, we get a parabola. And for when the eccentricity is greater than 1, we get a hyperbola. And for an infinite eccentricity, we get a line. Okay, so now calculating. Okay, so real fast, and you're probably noticing some A's and B's and everything. The A's are definitely from the major and minor axes. Okay, so finding a circle, circles, eccentricities does 0. Parabola and circles are really easy. Okay, however, ellipses, finding their eccentricities, you have to do the square root of a squared minus b squared over a for an ellipse. And we're not square rooting the bottom a, we're just leaving it as is. Okay, and for hyperbola, it's square root of a squared plus b squared divided by a. Okay, all right, and that's it for everything dealing with conics. Hopefully you got everything and were able to understand everything. Eccentricities, not exactly needed to be known, but it's actually kind of cool to know that you can look at an eccentricity of a conic and actually figure out what kind of shape you're dealing with. All right, I'll talk to you later. Bye.